lot of moons. Okay. You mentioned position and velocity. We're going to simulate in time steps. Then results in things. Potential energy. Kinetic energy is the sum of the absolute value. Okay. Energy after 100 steps. I don't want to screw around with parsing. I think we're just gonna say O2 comma. Yeah, I'm on a slightly different setup than normal tonight, so board is I'm in a little bit different position relative to my keyboard. I'm gonna be slower typing, which means I probably don't have much of a chance of the lead, right? But hey, we'll still have a little bit. Art. Or okay. So we're basically going to three. X is the same. The velocity doesn't change. Okay. And grid. Go for total energy. Okay. So I basically have to sim thing. In each step, we update them by applying gravity. So we change velocity. We based on position, we change velocity. Then we update. Okay, so the velocity starts. Okay, position. actually. Uh, position and velocity. By position, right? Okay, so we only care if they're different. If other I can just go if the other one is bigger, then other smaller, then that one increases, then that one moves. Up. I gets the velocity added to it. Velocity. Rho is 2. So now we got a thing. And dock. Come on, dock. Two gravity. 2. Oh no, because that'll apply them twice for each one. I only gotta. I gotta do only pairs. Um. Right. 0. On. Oh, it is a list, so it does have count. I know. Okay. Start it at 1. Have that problem anymore. So this should apply as gravity, and have applied gravity to everything. Velocity. Uh, Start way. Out for the moment. See how far off we. Right. 0, 7, 8, 1. 2, 2, 1, 0. That looks good. And 2. All right, that looks to be working. Values, additionals. Okay. Ten steps. That's not right. Oh, potential multiplied by. I'm not gonna have it output this stuff. It's just slow because it's outputting it all. 79. Yeah. Okay, 1,000 steps. Off. Okay. should have left this on. Oh, I am not even running for my puzzle input. That's stupid. Shoot. All right, well, let's take the couple of minutes that I have to wait. A minute that I have to wait. Fill in another symbol. And 40. Let's just reconfirm my initial. Negative 4, 3. 9, negative 4, 6. 7. 11. Negative 9. And 6. Answer. All right. Okay, so we're looking for where positions and velocities are an exact match. Oh, find a more efficient way to simulate the universe. Awesome. Okay, so if I have to be able to go. Wow, that is billions, which means that even if I could do it. Well, that's only. It's only billions, and a CPU is a billion cycles a second. But the problem is, if I have to go, if I could go through 4 billion things, a previous point in time, because our problem becomes, I might be able to sim the universe fast enough, but I have to do something clever to dupe check the universe. Because if I have to be able to get through 4 billion states, I only could probably, I could probably got 16 megs of memory, or 16 gigs of memory I could allocate, which means I could have at most 4 bytes to represent my universe state and be able to keep 4 billion times 4. So let's take these. Let's get the naive thing running first. Let's just actually sim it for. I'm going to do some really big numbers here without too. Let's do 4 million for. Darn it. Oh, hey, I don't know what button to hit, but that was the one I wanted. I can do 4 million steps in about a second and a half. But if I need to get to 4 billion steps, um, the 4 billion steps would be an hour or so. And that's just to simulate it. That's not dupe check it. Let's see, I don't need energy calc anymore. But I was doing the energy calc to the end anyway, so that didn't matter. And I could unroll the loops. Since I know there's only 4. I don't think that's going to help enough though. Would I'd have to get a way bigger boost than I think I can get from this. Yeah, see, it gets me from 1.4 to 1.2, but all that does is moves it from like an hour and 20 minutes to like, or sorry, an hour and a half to an hour and 20 minutes. Still not fast enough. There's got to be a trick I'm missing here. Okay, what's the algorithm we're thing is I don't think like something like vector math or streaming sim instructions, I don't think is going to let me get fast enough to do. It's almost like I've got to find an analytical solution of a simulation solution. Um, Last time we had one of these, it was all about recognizing the pattern. We had one of these last year with like potted plants or something, and you recognize the pattern, and then you could figure the pattern and devise an analytical, like a simple function that would give you for an arbitrary step. Even that doesn't help us because I have to know when state repeats, which I have to know because I'm not looking for something that matches my initial state. Curious. All right, so there are people getting solutions already, which means it shouldn't be too monumentally hard. I just don't know how to get there. This might be another one of the days when the math geeks win. All the boom's positions and velocities exactly match. Eventually returns to the. So we know that once it gets back to the initial state, because the way our rules work, we'll be stuck in that loop forever. But that doesn't help me because I don't know at what point it comes back into the loop because there's no guarantee that it comes back to the initial state. velocity thing be for only action. Oh, it was already core. All right, core 3. Yep. Cool. All right, so I can use the vector classes. Thing is I don't think the vector classes are going to give me. I know I can make apply velocity easy because that's add. It's this one that is the vector primitives. Even so, even if they gave me factor 10, all these things are supposed to be solvable within a minute or within a few seconds on a normal performing thing. Position, velocity, exactly my. Like, part of my problem is the size of that number means even my dictionary to track it is going to require a ginormous amount of memory. Um, all right, let's try this. That energy number might prove. Oh. Said did at right. That doesn't sound right. Oh, because they all were. Pull. Well, what if we were to assume that they only come back to the initial state? Effectively, we're trying to find the repeat. Okay, so all of our scenarios start out with initial energy of 0. That's got to mean something. No, because see, even energy 0 doesn't work. Because I hit a 0 state that is different than the state. All right, so there's gotta be something to do with that though. Um. Okay, so the other thing could be is it could have something to do with what these numbers are. There's some formula from what these numbers are to here. Oh, wait a second. I have 3 vectors. Oh, I could solve this in the x, y, and z separately. Because there's no interplay between x, y, and z. So if I could generate the sequence length for x, y, and z individually, I then find the least common multiple of them. All right. Okay, I can do this. Okay. Uh, parts. So partless. Part plus. Okay, so that. Oh no, wait. Actually, all the rules still apply. I'm just going to in by 1 level. Oh, this is clever, clever, clever. Okay. So, let's see. Yeah, I could optimize. Well, actually, yeah, I should optimize this. That with that. Sharpen gold. I don't remember how I'm supposed to. Think this is supposed to be a prime, but I never remember what the rules are. That's why I like ReSharper's thing; it just magically does it. But now that I'm overriding get hash code equals, I can start. Oh shoot! But these are mute. That'll work. Um. Let's just go with. XOR operator. Effectively, I'm just going to XOR hash codes together. Okay. All right. Validation step. Break. Break at that. Um. Three. All right, so now I just need a. I'm just gonna move that off to the other monitor while it runs. Yeah. Cool. So if I put in 19, 29, and 45, 24. Oh, no. Okay. I gotta take one off of all these. 18, 24, 772. Okay, and then 8, 9, 4703. I only took it off the first one. 4, 6, 6, 774, 924. Okay, and so for the real answer, 161,428, 116,328. This works. I mean, this is insane. Oh shit, that's the answer. Oh, that is too fucking clever. Oh, that is clever. Man, that took me way too long to figure out. So, and it's still like here, this still took me 31 seconds. So, I'm doing too much array manipulation, some other things, but that is the one general thing with these advent of code things is generally you have to really screw your algorithm up. Sorry, you have to screw up your implementation pretty badly of your algorithm to make your performance really matter. Most of the time, the trick is in the algorithm. The trick is not in the um, actual approach. So, like for example, the trick here was realizing that you have to find the pattern in X, Y, and Z separately because X, Y, and Z don't actually interact with each other. And so it's figuring out that if you want to know when the full system simulation repeats, you just have to find the repeating pattern in X, the repeating pattern in Y, the repeating pattern in Z, and then figure out when those repeating patterns align with each other. So, like for this first one here, yeah, for that first scenario, it's all about we figured out that X repeats in so the 19th step X repeats, which means it repeats in 18 step intervals. Yeah, it does seem off to loop back to one. Oh, because I should have actually been finding a loop back to 0. I never put the initial state in the thing. All right, let's clean this up just a little bit then. See 0 because that'll tell us where we're looping back to 0. Yeah, here we go. Now we're getting the numbers that I actually fed into that least common multiple. Um, all right, so that'll give us the right numbers. Oh, I don't have. And we don't step count at all. Part use. You know, So now we're just back to a for loop. Okay. Turn an int. Okay. Cool. So then all I need to do is find the least common multiple. Again, I don't remember my high school math, so I don't remember. Yeah, we'll just rip somebody else's code off. I mean, isn't that what entirely what software development is? By repeated division, great. Oh, I gotta take the extra arguments out of here now. Not anymore. Overflow. Let's see. Long. Yep. How long it takes to spit out my solutions. Yep, there's my number. Cool. And now I'm on a NetCore app. I'm on NetCore 3, so any future weird stuff I can pull off from there too. All right. Well, oh yeah, I guess let's be good. At least if we're gonna steal code off of Stack Overflow, we should at least cite our sources. I would like to learn what I am doing and not just take from someone else. Ah, welcome to the opposite of what most of actual code. Well, no, it's generally a good idea to understand what you're doing, but this is effectively, again, this shows how much of high school math I remember, which is to say, not all that much. Heck, this is probably elementary school math. Let's see, this is. Well, I just made this call. Oh, darn it! See, now I'm code reviewing this code that I copied, and now I want to change it all. All right, so if B, we're just gonna flip them. Cool. Oh, want A is greater than B. B should be the smaller number. Less than B. Okay. So effectively, if we find some number times A that is okay, I guess that's sensible. If we could find some multiple of A that is A times this number is a multiple of B, then we'll use that. Otherwise, we'll... Okay, that works. All right, see, now I kind of remember it. Or so I'll say. Yeah, the LCM runs the end, so perf actually really doesn't matter with it. Oh, and by the way, this aggregate thing is just because I have a list of 3, and since my multiple can only do 2 at a time, I could have just done LCM of 0 and 1, and then take the result of that in LCM out of 2. Aggregate just kind of does that for me. It says take each of the things in the list in succession and call this determine LCM. They don't give it a seed. It will actually start with the first 2 items, or what will get called to this determine LCM. All right. This also would have been a little more tricky if we would have given us things that didn't loop back to 0 as our cycle point. That would have made things more complicated because you couldn't have just combined them with a simple least common multiple. Would have had to effectively find the first number that was n more than the cycle factor for each of the things. So like he could have set it up so that yeah, so that like x looped back to 1, y looped back to 2, and z looped back to 3. So I don't know, that I haven't thought all this through. That might not actually be possible. Oh, it's got to be. Well, there might not be 2, as in if you have a loop, there might not be 2 different ways to get to a point on some point on that loop to actually get you started on the loop. Yeah, that would have been interesting because that would have made this last part harder because we would have figured out from the first part, we would have found like from position 20, we'd found a loop back to 1 instead of a loop back to 0. But and and then in that case, if 19 and 1 were not the same, that means the loop is actually from 1 to 20, not from 0 to 19 or something like that. But anyway, this is the one. This is the class of ones that just has potential to really throw people. There's one little trick you got to figure out, and like as evidenced, I spent a very long time trying to figure the trick because the thing I was actually trying to figure out was I thought somehow there was looking at this. There was a formula to go from these 12 numbers here to this 2772. Wasn't sure what it was, but it seemed like there should be something, and then it wasn't until I started trying to think, okay, how would I parameterize this? Is this like do I have 12 parameters polynomial solver thing to try to solve for? I was hoping I was gonna like some variation of this, and I plug out that, but that was when I realized that there was not actually any connection between X, Y, and Z. So you could simulate them each independently and then combine the results together. So yeah, if you tried to, yeah, because my answer was billions, billions. This is millions. This is billions. So mine had 500 trillion steps. All right. Well, that'll be signing off. No points tonight, but I felt this was a pretty good puzzle. Like it's a true puzzle. It's not a. I mean, it's a simulation thing, but it's find the trick to the simulation that is not actually given. So, yeah, there's a pretty good number who figured this one out. Okay, I didn't do well on it, but there's a lot. So, anyway, we'll call that a night. Probably be back again tomorrow night. We'll try this again. We'll see if maybe I can hit the leaderboard this time. Good night.